Specialist James Buckley making his third trip this morning, and Commander Michael Coates. This will be his second mission into space. His pilot, John Blaha, making his first trip, and James Bagian also making his first trip into space. They're all wearing space shuttle ties and suits this morning. After breakfast, the flight crew will get a weather briefing, and they'll be donning their launch and entry suits for today's launch this morning. Their traditional cake is sitting in the center of the table, and it's got the crew insignia as part of the decorations on the top of the cake. The patch was designed to capture and represent the energy and dynamic nature of this nation's space program as Americans continue to look to the future. And the colors of the United States flag are represented in the patch's basic red, white, and blue background, and in the border the 7 stars between the STS-29 crew members are a tribute to the crew of Challenger. Back on the launch pad, the ICE team has continued to make their inspections. They go first to the 0 level of the shuttle's transportable launch platform to inspect the tank's aft dome and the shuttle engines. Their next stop will be at the 135-foot level, which is where they are now, where they get a good view of the orbiter to external tank umbilicals. After they make their inspections at the 135-foot level, they proceed up to the 195-foot level, which is the point where the crew access arm extends from the service tower to the vehicle and affords a view of the orbiter's forward attach point to the external tank. The next stop would be the 215-foot level, which corresponds to the very tip of the tank. From there, they can see how effective the beanie cap or the gaseous oxygen vent hood is at collecting the gaseous oxygen vapors and preventing them from forming ice on the top of the tank. Before leaving the pad, they will make one last stop again at the 0 level of the mobile launcher platform before returning to the Launch Control Center. Charlie Stevenson will then make a brief report back to senior shuttle management concerning what they saw. The other members of the team include Greg Katnick, who is a KSC employee, and he will be operating a portable infrared scanner to measure temperatures on various areas of the tank, boosters, orbiter, and pad structures. Farouk Hanaidi represents Marshall Space Flight Center and will be measuring vehicle temperatures with a handheld infrared scanner. Close-up photo documentation will be taken by Zach Burns of NASA Johnson Space Center. Steve Copsey of Martin Marietta from Michoud is the external tank manufacturing representative on the team. Randy Steele of Lockheed Shuttle Processing Contractor will be collecting data, and David Huntsman, NASA Johnson Space Center, is the Level 2 representative on the team. And there's also a Lockheed Safety representative as part of the team, too. An inspection of the pad, mobile launcher platform, and space shuttle were made yesterday, and the external tank thermal protection system was documented prior to loading the super-cold propellants into the tank. An inspection of the pad and beach will be performed about 1 hour after launch to document anything unusual or any debris that could have fallen off during launch. Meanwhile, the closeout crew is at the White Room now, preparing for the flight crew's entry. And the flight crew is getting ready over at the operations and checkout building. And we are now at T-minus 3 hours and holding. This is Shuttle Launch Control. The last couple of missions, and they are quite a bit bulkier than the regular suits that the flight crew used to wear. Everything going smoothly here in Firing Room 1 and out at the launch pad. ICE team is continuing to walk up and down the launch tower making their inspections, and the closeout crew is continuing to configure the orbiter's cockpit for the flight crew's entry. Astronaut support personnel Sam Gamar is inside the cockpit at this time, flipping switches and putting everything in the right configuration for the flight crew's entry. Should be receiving video momentarily of the flight crew getting into their, here we are, we have the orange launch and entry suits. And his pilot, John Blaha, being assisted with his boots. This will be Blaha's first trip into space this morning. And mission specialist Robert Springer. And Commander Michael Coates, putting his helmet on right now. Across the room, we've got mission specialist James Buchli getting all of his gear together in the various compartments on the spacesuit there. And mission specialist James Bagian. The crew altitude protection system is what the new suits are called, and they consist of a helmet, a communications cap, a pressure garment, an anti-exposure, anti-gravity suit, and gloves and boots. During the flight, the crew wears more conventional clothing, such as t-shirts, shorts, or trousers. They are scheduled to be departing for the launch pad in about 15 minutes, as soon as they complete getting their gear on, and are expected to arrive at the orbiter's white room about 5:15 this morning and begin entering into Discovery's cockpit, getting strapped in, and making voice checks with test conductors and flight controllers. There's pilot John Blaha getting zipped up into his flight suit. Things continuing to go smoothly here in the Launch Control Center and at Pad B. External tank now loaded and is in a stable replenish mode. Will be just until a couple of minutes prior to launch when the tank is pressurized for flight. At T-minus 3 hours and holding, this is Shuttle Launch Control. The limit is 12 knots, and right now we're looking at between 8 and 11 knots right now. ICE team is still at the launch pad now, making their final assessments. They'll be coming back to the Launch Control Center and reporting their the facts and observations to management here in the flying room. Now just about a half a minute away from picking up with a countdown. Three, two, one. T-minus 3 hours and counting. The next built-in hold will occur at T-minus 20 minutes, and that will be a 10-minute built-in hold. And there will be one final hold for today at T-minus 9 minutes, and that hold will be for 10 minutes also. The tracking and data relay satellite is the primary objective of this mission, and it will be deployed from Discovery's payload bay about 6 hours and 13 minutes after liftoff. The Tejas and its inertial upper stage were closed out for flight on Thursday, and the payload bay doors were closed for flight Friday morning. The Tejas and IUS were transferred from the vertical processing facility to Pad 39B on January 17. TDRS arrived at KSC on November 30th, and its IUS arrived December 27. 2 days later, the satellite and upper stage were joined together, and all integrated tests were performed the first week of January. As part of those tests, astronauts James Bagian and Robert Springer participated in the mission sequence test, which verifies payload functions that occur post-launch and during deployment. The Tracking and Data Relay Satellite, called TDRS-D, is the fourth TDRS communications spacecraft to be launched aboard the Shuttle, and this completes the constellation of on-orbit satellites for NASA's Advanced Space Communication System. One of the TDRS satellites was lost in the Challenger accident. Once on station in the geosynchronous stationary orbit, this satellite will replace the partially degraded TDRS-1 over the Atlantic Ocean. TDRS-1 will be moved and will operate as an on-orbit spare. TDRS was developed to provide orbit determination and data acquisition support to scientific and application satellites in near-Earth orbit and to the Space Shuttle. The TDRS system can provide real-time coverage for at least 85% of each orbit of user spacecraft. The former ground station network could provide coverage for about 15% of each orbit. The TDRS system will replace many of the ground stations in NASA's Spaceflight Tracking and Data Network and extend its capabilities. We're standing by now to receive video of the flight crew departing the operations and checkout building, and they will head to the launch pad. They'll be leaving in the standard traditional astronaut van, and it takes about 20 minutes to get out to the pad. The TDRS satellites are designed and built by TRW's Space and Technology Group out of Redondo Beach, California. NASA leases the TDRS complement of services from Contel from Atlanta, Georgia, which is the owner, operator, and prime contractor. Primary users of TDRS system have been the Space Shuttle, the Landsat Earth Resources satellites, Solar Mesosphere Explorer, Earth Radiation Budget Satellite, and Space Lab. They will be joined in the future by the Hubble Space Telescope, Gamma Ray Observatory, Upper Atmosphere Research Satellite, and others. And we have the STS-29 flight crew now leaving the operations and checkout building. There's Commander Michael Coates and Pilot John Blaha, Mission Specialist James Buchli, and Robert Springer. Going down the elevator, followed by Don Putty, Rick Nygren, Dan Brandenstein, and they'll be making their way down to the first level and getting into the astronaut van. And here's the flight crew down at the first level, ground level. Commander Michael Coates, Pilot John Blaha, followed by Mission Specialist Jim Buchli, James Bagian, and Robert Springer. Flight crew is being greeted, and I'm sure lots of well-wishers standing by watching them get into the astronaut van. Last time the flight crew was here was for the terminal countdown demonstration test. That's about a 2-day test, and the flight crew comes down and suits up and climbs aboard the cockpit and performs their voice checks and switch configurations in the cockpit just as they would perform on launch day, and gives them an overall dress rehearsal for launch day. They also receive training at the 195-foot level for emergency egress at the launch pad if that would become necessary. And everything appears to be going right on time this morning. Got an overhead shot now of the van leaving from the operations and checkout building. That building is located in KSC's industrial facility, several miles away from the launch pad. The van is led by security. With just a little over 3 hours to go prior to the opening of this morning's launch window, everything is continuing smoothly. The ICE team is finishing up with their inspections at the pad, and the closeout crew is continuing to prepare the orbiter Discovery for the flight crew's entry. And launch team members in here continuing to perform their task that would lead up to an on-time liftoff at 8:07 a.m. this morning. At T-minus 2 hours, 51 minutes, 44 seconds, and counting, this is Shuttle Launch Control. Checks with the landing and recovery director here in the firing room have been made between the convoy commander at the shuttle runway and at here in the firing room. And the flight crew now on the 195-foot level at pad B. We're looking at a Series 6 car mounted in the on the pad there at the 195-foot level. They're now walking across the orbiter access arm and now into the white room. Closeout crew members will be assisting flight crew for the getting into the cockpit. They'll go one by one, get strapped in, and then the hatch will be closed for flight.
RPS OTC 212. CPVD OTC. This is CVD. 99. Didn't work.
This is shuttle launch control at T-minus 9 minutes and holding. It appears the upper level wind situation is going to allow us to proceed almost launch. We are still in the discussion stage at this time. We are getting ready to go ahead and prepare to pick up with the launch countdown at the T-minus 9 minute mark. We do need an additional 7-minute warning is what discussion has been going on between the test director and the launch director. Time is needed to run a status poll of various management, make sure that no system has any reason that they cannot proceed on with launch today. And in addition, the inertial upper stage computers are switched to the flight mode at launch minus 11 minutes. So there's another couple minutes that are needed prior to coming out of the T-minus 9 minute hold.
Go ahead. Okay, did we plan to hold at 5? No, sir. I copy. On to 6 minutes.
And at this time, the mission management team is conducting a poll of the team members. This is the team is composed of NASA and contractor counterparts representing the major flight hardware elements of the space shuttle vehicle, and getting a status from them, making sure they are ready to come out of this hold at this time at T-minus 9 minutes. The new T0 time would be 9:57 a.m. Eastern Time. Mission controllers in Houston also polling the team members to get a go to pick up with the countdown.
OTC, CPVD. Go PVD. We can give you 959, 960, 962, 61, and 63 are not performed. Copy that. Team 26. OTC, CHGD. Go HGD. Okay, I can give you step 1005 now. 1005, copy. Countdown clock will start in 4 minutes on my mark. 3, 2, 1, mark. Launch director up, manager, 161. Launch director, go ahead. Yes, sir. The mission management team is hold, and you're go to continue to count the line. I copy. Thank you, sir. And MTD, when you're ready to come out copy. JRPS, OTC. JRPS. Yeah, another recorder.
And we did get the go from Mission Management Team Chairman Bob Crippen, who has polled the team members and has given his final go to pick up with the launch countdown and press on toward launch today. Countdown clock will be picking up in just a couple of minutes.
The ISL. Go ahead. SRB power up complete. Copy. Count clock will pick up in 3 minutes on my mark. 2, 1, mark.
NTD Flight 212.
Go ahead, Flight.
Do we have a go ahead and activate the orbiter recorders and get the MADs going?
Yes, sir, go ahead.
Okay.
ISL, you'll see MADs and orbiter recorders come up shortly. The countdown clock will start in 2 minutes on my mark. 3, 2, 1, mark. The countdown clock will pick up in 1 minute on my mark. 3, 2, 1, mark. AFTD copy.
Just a few minutes away now from picking up with the countdown.
Copy.
Countdown clock entered this hold at T-minus 9 minutes at about 7:48 this morning. Standing by now momentarily to resume at T-minus 9 and counting.
1, mark.
T-minus 9 minutes and counting.
Sequence has been initiated.
And the ground launch sequencer has been initiated.
The ISL. Go ahead, recorders are activated. No problems observed. Copy, thank you.
T-minus 8 minutes, 30 seconds.
Flight OTC, receiving the transmission of FCC 10101 to 12101.
T-minus 8 minutes and counting.
TLP OTC, configure fuel cell and essential bus source switches.
And orbiter test conductor has requested them to configure the fuel cells for launch. Coming up on T-minus 7 minutes, 30 seconds, and counting.
Go for OAA retract.
And we have a go for orbiter access arm retract. Arm is being retracted back into the launch configuration. This arm can be extended in just a few seconds if necessary. T-minus 7 minutes and counting. At T-minus 6 minutes, the orbiter test conductor will give pilot Blaha a go to perform the auxiliary power unit pre-start.
ARPS OTC, start the APU and hydraulic strip chart recorders. Got recorders running. ELP, perform APU pre-start. APU pre-start in work.
Pilot Blaha confirms he is performing the APU pre-start. He is configuring switches in the cockpit to put the APUs in the ready-to-start configuration.
OTC APU pre-start is complete.
T-minus 5 minutes, 30 seconds. Mission Control has transmitted the signal to start the flight recorders. The two recorders will collect measurements of shuttle system's performance during the flight for playback after the vehicle is in orbit. Coming up on a go for APU start at the T-minus 5 minute point. T-minus 5 minutes and counting.
Start. BLP, perform APU start. APU start in work. EDR, reconfigure heaters.
Commander Coates has been asked to reconfigure the orbiter heaters for launch. T-minus 4 minutes, 30 seconds, and counting.
OTC APU start is complete. Copy that.
Pilot Blaha reporting the APU start has been completed.
Okay, let's go for purge sequence 4.
And we have a go for purge sequence 4 on the main engines. The valves on the main engines are being opened to allow liquid hydrogen to circulate in the engine's nozzles and turbo pumps to condition the engines for starting. This conditioning takes approximately 3 minutes, and at the 1 minute point in the count, an engine ready indication will be given. T-minus 3 minutes, 30 seconds, and counting. We are now transferring to internal power and switching off the orbiter's ground support equipment power bus. At this point, Discovery is running off its onboard fuel cells.
Let's go for LO2 pressurization.
And we have a go for pressurization of the external tank, liquid oxygen tank. T-minus 2 minutes, 45 seconds, and counting.
ELT, clear caution and warning.
Pilot Blaha has been asked to clear the caution and warning memory, and the gaseous oxygen vent hood is now being lifted off the top of the tank and be retracted to the launch configuration. At T-minus 2 minutes, the flight crew will be instructed to close their visors.
Flight crew, this OTC, close and lock your visors, initiate your O2 flow, and have a good ride. Yeah, let's go for T-minus
1 minute 50 seconds and counting. We've had a go for liquid hydrogen pressurization on the external tank.
Minus 1 minute 30 seconds.
1 minute 30 seconds now from the launch of Discovery and its 5-member crew. At T-minus 1 minute, the heaters on the booster joints will be deactivated.
Minus 1 minute.
Just seconds away now from liftoff of Discovery. All systems are go. Coming up on T-minus 31 seconds. We have a go for auto sequence start. Discovery's 4 redundant computers have primary control of critical vehicle functions for the remainder of the count. T-minus 20 seconds.
15 seconds.
T-minus 13, 12, 11, 10. We have a go for main engine start. 6, 5. We have main engine start. 3, 2, 1. SRB ignition and liftoff. Liftoff of STS-29 as Discovery clears the tower.
Roll program.
Roger, roll, Discovery.
Mission Control, Houston. Good roll program confirmed. Three engines now at 65%. Standing by for the go at throttle up call.
Discovery, go at throttle up.
Roger, go at throttle up.
Mission Control, that call means all systems are performing well as the shuttle main engines have resumed their firing at 104% of rated thrust. Relative velocity now 2,400 feet per second. Climbing at a rate of 1,700 feet per second. Downrange distance 11 nautical miles. SRB separation, standing by for a performance call from Mission Control.
Discovery, performance, nominal.
Roger, nominal performance.
That call indicates Discovery's performance was good on the first stage with the solid rocket booster performance. Now have 3 main engines up and running at 104%, 3 good fuel cells, 3 good APUs, altitude about 250,000 feet, relative velocity 5,300 feet per second.
Discovery, 2-engine Ben Guerir.
Roger, 2-engine Ben Guerir.
Discovery now can make a landing at the transatlantic abort site, Ben Guerir, should one engine fail. Still have 3 good main engines at 104%, 3 good APUs, 3 good fuel cells. Relative velocity now 6,000 feet per second, climbing at a rate of 1,100 feet per second. Discovery now passing through 300,000 feet. As all positions here in the Mission Control Center report go.
Discovery, negative return.
Roger, negative return, John.
The call indicates Discovery can no longer make a return to launch site abort. Now 146 nautical miles downrange. Relative velocity 7,800 feet per second. They've passed through 340,000 feet and they're climbing at a rate of 600 feet per second. Now 190 nautical miles downrange, relative velocity 9,100 feet per second.
Discovery, press ATO, select Banjo.
Press ATO, select Banjul.
Discovery can now lose engine and still make a nominal orbit case. And if 2 engines fail, they could now make it to an alternate runway at Banjul, the Gambia. And we still show 104% on all 3 main engines.
Group Banjul, 109.
Roger, Group Banjul 109.
And you're pressed to MECO.
Roger, press to MECO.
Discovery now can achieve nominal main engine cutoff targets should she lose 1 engine. 3 up and running at 104%. Fuel cells producing 7.5 kilowatts. APUs at the proper temperatures and pressures and speeds. Downrange now 317.
Banjul, 104.
Second engine Banjul 104.
Discovery can now reach Banjul if 2 main engines should fail, and that would be at 104% power level rating for the remaining engine. However, we still have 3 good engines. Still climbing at a rate of about 70 feet per second. Downrange distance 380 nautical miles. Discovery now traveling at 15,000 feet per second.
Press, 104.
Second engine press 104.
Discovery can now reach main engine cutoff conditions with 1 engine up and running, 2 failed. We still have 104% showing on all 3 main engines. Good performance throughout the system. Downrange distance 516 nautical miles. Relative velocity 18,875 feet per second. Now now reached 3G throttling on all 3 main engines as expected, and we're standing by shortly for main engine cutoff. The main engine is now throttled back to 86%. Relative velocity 22,200 feet per second.
And we have a good MECO at 25.9.
Roger, MECO 25.9.
Mission Control standing by for Discovery to separate from the external tank, at which point they will perform a test objective. We've had good main engine cutoff, good ET-SEP.
Discovery, we see R1U failed off. No action required. No ohms 1 required. Your go for the DTO.
Roger, go for the DTO. No ohms 1 required.
That's ohms 1 not required.
Roger, ohms 1 not required.
The R1U referred to as one of the up-firing jets on the right side of Discovery, no impact. It's one of the small verniers. Also, the ship will be doing a pitch-down maneuver so that one of the mission specialists may look out the overhead windows and photograph the external tank as it falls away from the orbiter. Now 9 minutes, 50 seconds mission elapsed time. Good ascent for Discovery. She's currently traveling at 25,840 feet per second. Downrange distance 1,095 nautical miles. With an apogee of 100 nautical miles. No ohms 1 burn will be required. There will be an orbital maneuvering system number 2 burn to circularize the orbit at approximately 160 nautical.
Discovery Houston, we're with you through Tetris.
Okay, John, read it.
I read you loud and clear.
This is Mission Control Houston. We've had our first acquisition of signal through the Tracking and Data Relay Satellite East. Discovery heading into a circular orbit about the Earth of 160 nautical miles. They've performed a DTO on the way up to photograph the external tank as it's separated from Discovery. All systems clean as a whistle, no reports in Mission Control of any systems anomalies at this point. All looks well here about 12 minutes, 14 seconds into the flight.
Discovery, you have a go for APU shutdown on time.
Roger. Go for APU shutdown on time.
Mission Control at 15 minutes mission elapsed time. All still looking very good on Discovery.
Discovery Houston, we see you've stopped your maneuver. We're wondering how the view of the tank is, and also whenever you're ready, you can give us a debris report.
Okay, stand by, John.
That debris report is a planned report from the crew on the kind of debris they saw accumulating on their windows on the way up.
Okay, John, Jim's getting some real good pictures of the tank through the overhead. We can see it pretty well, and we think we're going to get some good pictures of it here.
That's good.
And Houston Discovery.
Go ahead, Mike.
Okay, quick observation here. We saw a few things come off in first stage at about 50 seconds and make some smears on the windows. Looked kind of like the tapes, the movie tapes that Don McMonagle had showed us of the picture paper stuff coming off and hitting the windows. Of course, as soon as the SRBs came off, it left a haze over all the windows, and then the sun angle was such that on my side I couldn't see out at all. Now that we're pointed down toward the earth, it's just beautiful. We can see a few smudges on the windows from look almost like bug smudges. And if you look out the side where the window, where the sun is on the angle just right, you can see that the haze is there, but it's not too bad.
We copy all that. Most of the smudges on the two forward windows or side windows as well.
Okay, most of the smudges seem to be on the forward windows, 3 and 4. There's a couple on the quarter windows, 2 and 5. You can see drops from the condensation from the fog this morning. The drops left some residue on the windows, on all the windows. And you can see that highlighted with a haze when the sun is just right.
We copy that, Mike. Discovery Houston, your OMS 2, nominal targets, take time, 39:58, Delta V, total 222. Over.
Okay, we copy big time at 39:58 and Delta V of 222.
That's good readback, Mike, and we'd like you to hold off on loading the targets until we can ship you a new state vector.
Okay, we'll hold off then. And we're done taking pictures and we can maneuver whenever you guys are ready.
We copy, stand by.
Mission Control, Houston, 20 minutes, 15 seconds mission elapsed time. While speaking to us about his observations of some of the smudging on the forward windows of the orbiter, Mike Coates also was overseeing the successful shutdown of the auxiliary power units. The crew...
Discovery, your state vector's coming up now.
Okay, John.
Crew also was watching through the overhead windows of Discovery as the external tank that helped carry them into orbit was passing ahead of and below them on its way to re-entry over the Indian Ocean. The goal of the maneuver they did just after MECO was to take pictures of the external tank. There's been some interest in that, as well as the amount of debris and smudging that accumulates on the forward windows, given some problems that were encountered on the launch of STS-29 and the loss of some tiles during that ascent. The guidance officer currently is updating the inertial platform of Discovery. New state vector has been loaded.
Your state vector's on board. You have a go to load your targets and maneuver to attitude.
Roger, John.
Crew now has been given a go, and they are making inputs to the general purpose computers, setting up certain items and executions within the computer system to set up for the circularization burn, OMS 2, that will take place at a mission elapsed time of 39 minutes 58 seconds. The delta V, or change in velocity, will be 222 feet per second, and that will circularize their orbit at about 160 nautical miles. And we have a report that Discovery is now moving again, maneuvering to the attitude sufficient for the orbital maneuvering burn. Mission Control, a report from the mechanical systems section of our control center that the external tank vent doors and umbilical doors on the belly of Discovery have closed.
Discovery Houston, for Mike, we'll be watching you for most of the burn, and then we'll lose you shortly after, and we'll be picking you up through Tidris West at approximately MET of 5-1.
Roger, John.
Mission Control, Houston, we're standing by for the orbital maneuvering system number 2 burn in about 1 minute and 55 seconds. All smooth and nominal aboard Discovery. Propulsion Systems Officer has reported that OMS engines are at the proper pressures. Mission Control, the OMS 2 burn has begun. All looks well at the moment. Burn will give a delta V, or change in velocity, to the Discovery of 222 feet per second. And we'll circularize our orbit at about 160 nautical miles. Two big OMS engines on the back end. Discovery still firing. Mission Control, Houston.
Remember, Houston, we watched it through the burn. We got about 40 seconds left. If you get to SM Ops 2 before we pick you up through Tidris West, you can expect that you may get a fuel cell water relief line temp message. If you do, no action required at this time.
We copy, John.
Mission Control, Houston, Discovery shortly will pass out of range of the tracking and data relay satellite. She's now just east of Madagascar over the Indian Ocean, about to go through the short dropout and coverage between the two Tidris satellites. The ohms burn completed on time as scheduled. All looked well with that system. As the crew's going over the hill, Capcom J.O. Creighton with a heads up to them that they might expect to get a computer master alarm. That's due to the software mode that they're in now. The current ops program has a limit on it for a certain water line temperature. Rather than change that limit, they're going to just let the alarm ring, turn it off.